Hello, I'm Manisha Sahoo. My roll number is 21MT10029 and I'm from section 16. For my DIY assignment 3, today I will be disassembling an electric iron, which is an inevitable item in our daily life. Let us first identify the parts of the electric irons externally. So this is the handle. This is the temperature controller, which we use according to the fabric we are using. Like some fabrics require less temperature and some require more. So according to that, we control it. Here is a neon bulb which lights up when we use the electric iron. The base is made of steel. So now let's start the disassembly. Okay, so now we have disassembled the electric iron. Now let us identify the different components of the electric iron. This is the heating element. Inside this we have the nichrome coil, and once AC supply is applied to this, the nichrome coil starts getting heated, and hence it is insulated by magnesium oxide powder, which insulates this coil from the metal case. When the current flows through a heating element coil continuously, the temperature of the coil will become uncontrollable. So here is now the importance of the thermostat comes. So the thermostat is used to sense the base plate temperature and switch off the current flow to the heating element coil. The thermostat has here, as you can see, the thermostat has the input terminal, the output terminal, there is a contact spring here, and we have a bimetallic stripe here. So now, what is the bimetallic strip and why it is used? Bimetallic stripe connected here is used to sense the temperature of the electric iron. When the base plate temperature increases, the bimetallic stripe bends and pushes up the contact spring. It bends and pushes up the contact spring. Because of this pushing force and spring tension, the contact points disconnect. Here there are contact points. It's not clearly visible. Here it is. The contact points disconnect, and it stops the current flow. When the base plate temperature decreases, the bimetallic stripe comes back to its normal position and contact points connect again for current flow. Here, the phase line is connected to the input terminal of the thermostat, and the neutral line is connected. The neutral line is connected to the first terminal of the heating element. The thermal fuse is connected to the first terminal of the thermal fuse is connected between the output terminal of the thermostat, this one, and the second terminal of the heating element, this one. And the neon bulb is connected to both the ends of the heating element. Here the neon bulb is connected. And the earth line is connected to the body of the electric iron. When we switch on the electric iron while the control knob is in high position, current flow to the coil through the thermostat without any interruption. The current comes from here, it flows through the thermostat and travels through this path, and here the circuit is completed like this. When the coil temperature reaches, for say example, above 200 degrees Celsius, the thermostat contact points disconnect and stop the current flow. Then when the temperature reaches below 150 degrees Celsius again, the contact points connect again and the current flow to the coil, and hence again the base starts getting heated. When we rotate this knob to low temperature, the knob presses down the spring and makes changes in the spring tension and disconnects the contact points early than before. So the iron box temperature doesn't go higher than the particular temperature and keeps the iron box at a low temperature. The thermal fuse is used to protect the coil and avoid firing when the thermostat fails and overheats the iron box thermal fuse. And hence it stops the current flow to the coil, and that's how the electric iron works. This was the total mechanism. So let's now assemble this electric iron again. Okay, so now we are done with the assembling part. Here the electric iron has been assembled just like before. Thank you.